Today's lesson video is going to cover solving inequalities that take one step and only positive coefficients. You'll realize why that makes a difference in a future lesson video. I recommend you have a pencil and paper to jot down some notes, might want a calculator today, and of course your growth mindset. This is the starter I use in class, so I'd like you to try number 1 by picking which of these symbols should go in between these two expressions. So for this one, you have to worry about order of operation. You need to multiply before you add. So 10 plus 3 is 13. 2, don't do the plus first. 3 times 5, then plus the 2 is 17. And 13 is less than 17. On number 2, both of these mean the same thing. A negative times a positive is a negative, and they're the same numbers. So negative 24 equals negative 24. On number 3, you have to add on this side because they're both negative, subtract on this side because they are different signs, and now you have to think about which of these is smaller. Well, negative 26 is further to the left on a number line, so it is less than. And then on number 4, 4 squared means 4 times itself twice. 4 times 4 is 16, versus this means 4 times 2, which is 8, and 16 is greater than 8. And then based on previous lessons, what does this symbol mean? Well, if you're reading it from left to right, it means less than or equal to. And when you graph it, will it have an open or closed circle? It'll have a closed circle because it has the equal to, and shaded in means it can equal a value. So on this slide, I want your opinion as to how much money does a rich person have, and try to say a specific number, not just a lot of money, because that could be very subjective. Okay, now hopefully you said a rich person has at least, or this much money or more, because if you said, let's say you just said a rich person has $1 million. Well, then I could say, so if someone has $2 million, they're not rich, because you said $1 million, like they have to have exactly $1 million. So saying that a person has at least $1 million tells me $1 million or more, which would make more sense, and is why we have our inequalities. So what about this one? Based on your opinion, how tall do you think someone must be to ride most roller coasters? They usually have height, requirements. So once again, hopefully you said at least a certain amount. Maybe you said at least 48 inches tall, or maybe at least 5 feet tall, or a minimum of 5 feet. That will tell me that many feet or more. Because if you just said 4 feet, or you just said 5 feet, that means I can't ride the roller coaster because I'm 6 feet. So you want to say at least. And then looking at Six Flags information, their minimum for most of the roller coasters is 54 inches tall. Other prior knowledge you need for this lesson is how to solve an equation, and you need to know what happens to both sides. The answer doesn't matter so much. So on this one, what would you do to both sides to isolate A? Well, plus 7 is being added, so you need to do minus 7 to both sides, and then simplify it and solve. What about on this one? Well, on this one, we're looking at the B on the right side, and negative 8 is being taken, we're having minus 8 from B. So to undo that, we need to add 8 to both sides and then simplify it to find the answer. What about here? Well, on this one, we have 4 times C. So to undo times the 4, we need to divide by 4 and then simplify it to find our answer. And how do we isolate the variable in this one? Well, we're having division by 6 happening, so undo division with multiplication, because 6 divided by 6 is 1, and we simplify it and we have our answer. Last thing I'm expecting you to already kind of know is how to graph an inequality. So which of these match the graph? Well, on this one, we have an open circle, so we're going to ignore C and D because the little equal to line tells us shaded in, and we look over here. Everything less is graphed, so therefore all values less, which is A. What about this graph? Well, on this one, it has a shaded in endpoint, so we're once again going to ignore these two because they do not have the equal to this time around, and we're going over here to the equal to. This is all values greater than negative 8. It's graphed to the right. Therefore, all values greater, the symbol is pointing the direction of the graph because the variable is on the left, and it makes this one true. So now we're going to cover the new topic of solving these inequalities. I've made a note here. You might want to jot down some notes so you know what to do with the different types. So on this one, I'm using my same strategy, circle the variable, dashed line to show what's going on both sides. Even though it's not an equals anymore, it's a greater than. So to undo plus 3, we need to subtract 3 on both sides, keep it balanced. This becomes 0. You'll have your x on this side, the symbol's going to stay the same, and then you're going to simplify the right side, and our solution is x is greater than negative 8. Now on this one, it's a different type because we have a minus 4 happening to the variable versus over here we had a plus happening. So on this one, we need to undo the minus 4 by adding 4 to both sides to keep it balanced. On this side, we're going to have m. This became a 0. The symbol stays the same, and then negative 1 plus 4 is subtraction, and is 3. Here's another type, because now we have multiplication by the variable, even though these symbols are changing, but the symbols don't change how you solve them. So on this one, we need to divide by 5 to undo multiplication by 5 here, and you'll get n, the symbol stays the same, and then simplify negative 35 divided by 5 is negative 7. Last type, technically, we have division happening to the y, undo division with multiplication. This will become a 1y. The symbol is going to stay the same, and then simplify, you'll get negative 16. I have one more to show you. It's not a different type, but it has the variable on the right-hand side. So what do you think we should do to both sides to isolate x? We want to add 7 to both sides to undo the minus 7. So this side will become negative 5 because you subtract. The symbol is going to stay the same, and then the x is going to come down. Now, a lot of people want the variable written on the left. It helps with graphing. It helps with checking to make sure your inequality is correct. So if we want this x on the left, we're going to move the x over to the left, and the inequality symbol has to follow it. For example, this here, the point was facing the x, the less than. So when I rewrite it and just reverse the inequality symbol, these are the same thing because x is less than negative 5, and up here x was less than negative 5. Now you have a few for you to try. So on this one, you should be doing minus 8 to both sides of the inequality. That will leave you with w is greater than negative 13. To graph it, we're going to have negative 13 as the endpoint. It's an open circle pointing to the right. And now we can check these because we have some math that we've done to make sure we have done it right. So here's the original inequality. I want to check that my solution up here is right. I'm saying all values greater than negative 13 will work in the inequality. So 0 is greater than negative 13. So if I put 0 here for w, take it away, Indiana Jones, like I've taught you. And then 0 plus 8 is 8, and 8 is greater than negative 5, so it is true, and the inequality is pointing the right direction. Here's the next one. On this one, we want to add 11 to both sides to undo minus 11. N comes down, inequality symbol stays the same, simplify. To graph it, we're going to do a closed circle because it's equal to pointing to the left. And then to check it, 0 is less than 52, so we could plug in 0 to this one. I like to use 0 because 0 is a simple number to check, but you could technically plug in any value less than 52 to do your check. So once again, plugging in 0, negative 11 is less than 41. We don't really care about the equal to. The equal to checks the endpoint. I'm checking that the graph is pointing the right way, and negative 11 is less than 41, so we are good. Next one. You're going to want to divide by 9 on both sides on this one to undo multiplication. So m is less than or equal to 3 becomes our solution. We'll graph it at 3, shaded in to the right. And to check this one, 0 is not a solution because 0 is less than 3, and our solution says all the values have to be greater than 3. So I could plug in 4, 5, 6, anything greater than 3 to make sure it works. Well, if I simplify this, 36 is greater than 27, so it is true. And our graph is pointing the right direction and way. What do we do here, and what's the solution? So division is happening, so we need to multiply by 5 to undo it. Y is less than 25. To graph it, open circle at 25, pointing to the left. And on this one, we can check using 0 again, because 0 is less than 25. 0 divided by 5, anything divided by 0 divided by anything, excuse me, is 0, and 0 is less than 5. So it works. Last one for you to try. Well, on this one, the variable is on the right side, so we need to undo this one with a minus 77. This would be subtraction. You'll get negative 67 is greater than x, or to rewrite it, x is less than negative 67. So to graph it, we're going to do an open circle at negative 67 pointing to the left. And to check it, 0 is greater than negative 67, so we have to choose something less than negative 67. I'm going to plug in negative 70, that's over here. If we check it, 10, this simplifies to 7, and 10 is greater than 7. Now, for your practice today, I would like you to do 5 just graphing inequalities on Delta Math. Once again, it has a timer, which I don't like, so I've set the timer to 10 minutes. These should not take you more than a couple minutes total, so the timer should not worry you. And then I want you doing 1 two-step equation practice. This is an equation because I want you to review, distributive property equation, and 1 multi-step equation. So 8 problems total to practice. See you on the next lesson video.